In this lecture, we will introduce the queue abstract data type. Just like stacks, queues are also lists. The difference though is, remember with stacks, inserting and deleting are both done at the same end. With queues, we actually have insertion done at one end and the removing done at the other end. In fact, a queue is usually considered a first in, first out queue, or a FIFO queue, where the idea with this is the first thing that's added to the queue is the first thing that's going to be removed. The queue works just like a line at the movies or the grocery store or the DMV, where the first person that enters the queue, that joins the back of the line, is the first person to reach the front of the line and then be serviced, depending on what type of line it is. Now, the queue does have two main operations, just as how stacks have two main operations. We first have what's called onQueue, and this means that we're going to insert an element at the end of our list. Usually this end of the list we call the rear of the list or the back of the list. The second operation is called dequeue, and this deletes and returns the element at the start of the list, also known as the front of the list. Now, to implement the array, we can actually use any list implementation for queues. So we can use linked lists, we can use arrays. Both are perfectly fine, and they give fast, constant time running times for both operations, for onQueuing and dequeuing. Now, what we're going to do is we'll go over how to implement the queue using an array. We're not going to worry about discussing about it for linked lists, but you can probably take some guesses on how to go about doing it. So for arrays, what we're going to do is for each queue data structure, we're going to have the array, which in this case we'll call the array, and then we'll also have variables front and back that will keep track of the positions of the ends of the queue. And then we'll also keep track of the current number of elements that are in the queue. So we'll let current size be this variable that tells us how many items are in the queue. Here is a simple example of the queue using the array as our data structure. So we have a couple things in the middle, and then we also designate our front and back positions. One thing that you should notice right away is we don't have everything on one end of the array, and this is intentional. As we will see, when we remove and add stuff to the queue, we're going to end up changing where the ends of the queue are. If we want to onqueue an element, let's say the element is x, here's what we need to do. We first need to increment the value of current size and the value of back. We would then set the value of the array back to x. Now let's say we want to dequeue some element. Well, what we would need to do is set the return value to the array front, so that gives us the element at the front of the array, and then we need to decrease the value of current size because our queue is getting smaller, and then we would need to increment the value of front so it would point to the next item in the queue. Now there is one problem that we need to note. What do we do if we get to the end of the array? I mean, we are increasing the values of front and back, so at some point we're going to get to the end of the array and we don't have anywhere else to go. But one thing we could do is we could increase the size of the array, we could increase its capacity, but this usually isn't necessary because most queues are pretty small. After all, we've most likely dequeued several elements, which means that we have a lot of extra space in the front. So why not take advantage of that space in the front? So what we can do is whenever our front or back variables get to the end of the array, we'll wrap them around to the beginning. And this is what we call a circular array, where we go to the end of the array and then we'll just go back to the beginning. Let's do an example of onqueuing and dequeuing some elements just to kind of see what happens with our queue. Let's suppose this is our initial queue where we have two elements in here. The front of the queue has a 2 and the back of the queue has a 4. So let's say we were to onqueue a 1 into the queue. So we're going to increment the value of back by 1, but notice we're at the end of the array. So what we're going to do is we're going to move back to the front of the actual array. So we'll move it to the beginning, and that's where we'll insert our 1. We'll then call onQueue3, so we'll add 3 to the queue. Once again, we'll increment the value of back by 1, and then we'll insert the 3 at that spot in the array. We'll then call dequeue, where we just need to move the value of front. Yes, the 2 is still in that spot in the array, but we don't need to worry about changing it to something else. We just need to increment the value of front, so that way we know the front of the queue is now where the 4 is. We'll then call DQ again, and notice that since front was at the end of the array, we need to wrap it around to the front of the array. So we just move it over to the very beginning, so now front is where the 1 is. We'll call DQ again, so we increment the value of front, and notice that now we have both back and front pointing to the same element. That's perfectly fine because here we only have one element left in the queue itself, so it makes sense that both front and back are going to point to the same element. Finally, we'll DQ one more time to remove everything from the queue. So we're still going to increment the value of front by 1, and you might think this doesn't look right because now back is ahead of front, but this is okay because if we were to call onQ, we're going to increment the value of back, so that way both front and back are pointing to the same thing. So this is perfectly fine to move the front to have it be ahead of back. Now the extra code that we would need to actually wrap around the array is pretty simple. It doesn't really take a lot of extra work because whenever we increment either back or front, if we increment it and it causes it to go beyond the array, we'll just reset the value to the first position of the array. So it's just a couple of extra lines of code. Now, one thing we could do with the implementation is we can actually do this without having to keep track of the size by using the front and back values. But it is a little tricky to do that, so it's not recommended, but it is possible if you didn't want to keep an extra variable for tracking the size. One thing that it is recommended worth doing is to include error checking. Like for example, we don't want to do a DQ operation when the queue is empty. So you should check to see if the queue actually has something before you try to DQ. Likewise, you want to check to make sure that your array isn't full before you try to add something to it. Now, a question that is worth asking is, could we use already existing implementations to implement this queue? So could we use something like myArrayList to implement it? The answer to that is yes, we can do it, but we would have to make a lot of modifications because we would need to handle a circular queue. We don't have that here. So in this particular case, it's probably best to use our own implementation for the queue.